So let's do a couple more examples like that one, but a little bit different. Subtracting fractions with unlike denominators. Here's one where there's two different denominators, 7 and 8, and you're going to notice that if we take the first step from the other one we did, we want to see if the smaller or if the larger denominator is in the smaller denominator's times table. And the question is 8 in the 7 times table? Well, the answer is no, it is not. 8 is not in the 7 times table, okay? Which means we have to do a little bit deeper digging to figure out what they both have in common. So what I'm going to do is I'm going to take the two denominators, 7 and 8, put them down here. And I'm going to write down, and of course, mentally, if you're really good at your times tables, you could probably do this mentally. But for now, let's do it in writing so you can see what we're doing. We're going to write out the times tables to a certain point for each, okay? So I'm going to write down the 7 times table, maybe till about, I don't know, 10th number. 7, 14, like I said, if you know your times tables, this will be a piece of cake. 21, right? I'm just going to keep going, right? Let's see. I'm going to keep going for a little while longer until I can't fit anymore. All right? We'll stop at 63. Now I'm going to do the 8s, okay? I'm going to go 8. See how far I can go with that. What am I doing? 32. Sorry about that. It's a 32, not a 36. Okay, I'll stop at 72. So these are the times tables for 7 and 8. And what I have to do is I have to look for the number that both of them have. Not only the number that both of them have, because sometimes there's more than one, but the lowest multiple, the lowest number that both these times tables have. And if I go down as far as I can, I will notice that this number right here is in both times tables, 56. And think about it. 7 times 8 is 56. 5, 6, 7, 8, right? So 56 is going to be the common denominator now because nothing lower works. 56 is the first number that both times tables have in common. So I'm going to do the same thing. I'm going to put the 56 underneath both lines. Okay? And now I have to figure out how to get them. Well, 7 times what is 56? 8, which means I do the 8 on top as well. 4 times 8 is 32. 8 times what is 56? 7, where it's like a little reverse division. I do times 7 above as well. 3 times 7 is what? 21. Now I'm ready. So the 56, of course, stays the same at the bottom as the denominator. Now I subtract the two numerators. 32 minus 21 is 11. And since 56 is not in the 11 times table, I am finished. Okay? My final answer is 11 over 56. Let's do one more, similar but a little bit different. Once again, the bottoms are not the same. Is 10 in the 8 times table? No, it is not. So now, once again, I'm going to have to do that digging. The good news is they're both even. So something's going to work. Now, I'm going to give you a shortcut with this one. Yes, your instinct is to say, oh, it must be 80, because 8 times 10 is 80. 7 times 8 was 56, so it must be 80. No. Think about it. You got a 10 here, right? Which means if you take 10, you have to take 10, cut that number 10 in half. What's half of 10? 5, right? What's 8 times 5? 8 times 5 is 40. Now I will ask you, is 40 in the 10 times table? Yes, it is. Which means 40 is the lowest number that both these numbers have in common. 80 is the next one over. Why go all the way to 80 when 40 is right there? So I'm going to put the 40 underneath for both, okay? Because 40 is my lowest multiple. And if I wrote out the two times tables, I would see that 40 is the lowest for both. Think about it. 10, 20, 30, 40. That's only the fourth number of the 10 times table. And you know 40 is in the 8 times table as well. 80 is all the way towards the end. So let's figure this out. What do I multiply by 10 to get 40? 4. Do the same thing on top. 1 times 4 is 4. What do I multiply by 8 to get 40? 5. Same thing on top. 2 times 5 is 10. Now I'm ready. Denominator 40 stays the same. I'm trying to get this in there. Okay. Now I just subtract the top, the numerators. 10 minus 4 is what? 6. So now I have 6 over 40. Now I'm going to ask you, look at these two numbers. Am I finished, or can I make it lower? Can I reduce it to lower terms? Think about it. What do you notice about both these numbers? No, 40 is not in the 6 times table, so you can forget that. But what are they both? They are both even numbers, which means I could cut them both in half. I could divide them both by 2. So let's do that, okay? What's half of 40? 20, right? What's half of 6? 3. So now I got 3 over 20. Now am I finished? Well, 20 is not in the 3 times table, right? And guess what? That's it. This is odd, this is even. I'm done. So my lowest and final answer for this is 3 over 20. Okay? So I'm going to zoom out. You can see all 3 problems. You could pause the video if you like, copy them. This first one was from the other video we did. We couldn't fit it in that other one. But anyway, couldn't fit these in that first one, so we just made 2 different videos. But these are the 3 types of examples. You've got one where the numerator or the denominators work. The bigger denominator works because it's in this smaller denominator's times table. You've got one where they don't work, but you'd have to multiply them both to get the common denominator. Here you've got one where the larger one is not in the lower one's times table, but it doesn't mean you necessarily have to multiply them both. There is a lower option because they're both even, and the 10 times table makes it easier, okay, because of the 5s. So there you go. All right. Hope you found those videos helpful. All right. See you later.